Hey everybody, I'm Chad.
And I'm Jack.
Hey, and you know, this is Lehawn. This is our robot. We let some of the neighbor kids, if they were good for their mother, drive it. And as you can see,
he's doing a little worse for wear.
a little worse for wear. But we've gotten a lot of requests, and Jack can tell you, of how we built our robot. Now, it's not important about how we're building it for a long term for the projects that we're working on. We just wanted to minimize how much stuff we needed to build to get going.
Not to mention, starting cost is really important, because if anybody else wants to do a project like this, your starting cost is going to be really important, because not everybody has a large amount of funds to go towards a project like this. So this is part of the reason why we're also making this video, because when we were building and designing this prototype, cost was a very important number for us, because it was going to limit how much we could do with Lehawn.
All right, so with that being said, Jack, let's go ahead and unwrap Lehawn. Now, we want to show you, so this is a very cost-effective robot. This is cardboard with a fancy face. It just made it more friendly. All right, so this is an Elite scooter body. So what Jack and I found was on Facebook Marketplace, what was it, like 6 scooter parts for like 150 bucks, I think we paid. So we were able to get 6 of these scooters. Now these scooters, a lot of times, and I'll show you here where this goes, there's a motor controller. And that motor controller, I'm assuming, uses like Modbus 485 to control it from a joystick. So if you can imagine, there's usually a chair here and somebody sitting in it and they're moving around. What's nice about starting with one of these platforms, at least from us, is there's some safety features. You can shut the brakes on it. And we're not using any of that motor controller. We're not using the joystick. We're not using any of the pieces that come with it. But Jack could tell you a little bit about why we did this back here. We'll start back. So let's start at the bottom of it, work our way up, and explain it. That sound good to you, Jack? All right, so let's start here. So these are the motors. So on the scooters, the motors are built into the chassis.
Big black cans.
Yeah, these big things here. These are the brakes for them here. And these are the tires. So when you're building it, there's a gear. I think it's right here. The gear's in here.
Inside of this gearbox here.
Yep. So when we got this was like somebody's scooter that wasn't working. So what we wanted to do was get it working. So the first thing we did was rip off the controller, did all that stuff. Well, we wanted to be able to disconnect the circuit. So what we did is on the motors, so you'll notice we have wires. So there's 4 conductors. There's a positive and a negative for each of the wires, but we can disconnect each of the wires separately. So that's why we did this. This is for safety, to be able to shut it down. Also, when you start rolling these tires, just think of it, you're also creating like an alternator, if you would, and that alternator goes ahead and starts sending voltage through our system.
It back feeds the shield for the Aurdino.
Yeah, so I think I can probably
that's
simulate
a no-go.
that. Let me see if I can simulate it. You should be able to see like it
Let's
kicking in.
see if the lights turn on.
Did they kick on?
You got to be going pretty fast.
See, it's not doing it because we closed it.
It's safety.
Now watch.
See that light's illuminating now.
It's doing that. So that's why we put these on here. All right, so that got it. So we got rid of that. We hardwired into the different motors, and they're all working. So one of these scooters, typically, if you can buy them used on Facebook Marketplace, but they typically come with 2 12-volt lead acid batteries. We went ahead and opted and bought a 25 amp hour, 24 volt, or it's 25.6 volt lithium ion battery. So it's a LifePool, LIFE phosphate, lithium iron phosphate battery. And that was about 150 bucks, I think, Jack.
And it was worth every penny.
Yeah, it just makes it much more reliable. We bought a cheap lithium compatible charger. I think it was about 15 or 20 bucks, and it charges our setup. So when we got this, so if you think now, okay, so we're at here, we got the battery, we got the disconnect for it, we got a cable here, but these were not on it because there's a chair mount here. So if you'd find one of these scooters, you'd have a chair mount. So what we did was we just got some threaded rod. These are plumbing
for sprinkler systems.
Is that what they were for? Sprinkler system. They're in the plumbing department. We got them at Lowe's, and we were able to screw it on and create a board here that was raised that allowed us a stable platform to be able to put our electronics. So that's what you're seeing there. So this is pretty simple. All right, so the next thing we want to do is we talked about being able to run power from the battery. To disconnect it, this is our positive. So when we want to send power in, you'll see it's on there, and we're sending power through the different computers. All right, so that particular setup gets us all the way through power in our electronics, and we're going to start with the electronics. Now, the most important part of our electronics is we're using an Aurdino Uno Wi-Fi?
R4 Wi-Fi.
R4 Wi-Fi. That is not what you see on top. It is what is underneath, and I'm going to be very sketch, and I'm going to try to unplug that because this is a shield, right?
Yep.
All right, so this is the Aurdino R4 Wi-Fi. So that is what we are running as our primary motor controller. And this shield, this is a cytron. So I cannot recommend this particular piece enough. This is an MDD10 by Cytron Technologies. That has worked wonderful. And you can see it plugs in just right like on top of the Arduino. Okay, so what that does is you've got settings to be able to run this in different PWM modes. So we have what we're running here is we have our positive and negative coming in at 24 volts, right?
Yep.
That is outputting 5 volts to our Arduino, right? So that is one of the functions that this does, is it produces the 5 volt out. So we have those two power cables coming in, and on top of that, we have the left and right motors. So you'll see this is one motor, and this is another motor, and these are our power connectors. There's some settings here on the pins that allow you to set what direction the motor is,
what pins they go to.
Yeah, what pins. So because it's sitting on top of it, it's going to use different pins. Those are so these two pieces here are our primary motor controller. And the reason why that's important is we've set this up to use WebSocket. So we send an actual command to the Arduino from our other computers. What I wanted to do was take off any processing off of the Arduino and leave it only to do the motor controller. And I also wanted to be able, for being the building models and stuff like that, I wanted to have a left and right component that we can have it issue commands to. So that is how we built the model. All right, so the next two pieces we have here, this is a old particle IO. No, I'm sorry, this is the GPS wing for the Raspberry Pi, right?
Yep.
I believe this one is the
accelerometer. We were never able to.
We were able to get it, but I think we're going to need to use a Kalman filter on it because it's real noisy.
Super noisy.
Super noisy. And this one here was what our
low-level logic converter.
Oh yeah. So this one, if you want to be able to run a connection from a Raspberry Pi to an Arduino, because I believe these are on 5 volts, and the Raspberry Pi runs on 3.3. You'll need some of these, and this protects them from burning out the boards.
Because the reason we had to do this is because we wanted to have a safety pin, so that when these two weren't talking to each other, it would kill the robot. This was when we were GPS locking it, so if it would go outside of that boundary, it would set this pin to low, and the Arduino would see that signal and say, stop everything you're doing. And that was the reason for this. Otherwise, I don't think we would have needed it.
So, but I don't think we were using the Raspberry Pi for some, so we could SSH into it and be able to send some commands. We switched to using a headless Mac, and let me explain what a headless Mac is. So Jack had a MacBook Air, 2020. It was an M1, and the screen went out on it. And so I gave him one of my old MacBook Air, and he didn't miss a beat. But I had now a MacBook Air that I could run remote desktop on. So typically right here, we're sitting a MacBook Air, but the screen doesn't work on. But it's okay because we're remote desktop it in. Everything's going across Wi-Fi. It's not the best way to do it. We're going to work on that. Then we're using webcams. So right now, this is, we've kind of hacked this together the best we can. This is a PEX fitting. So I believe this is PEX or something like that. This is a piece of a lawn sprinkler, and this is also another piece of plumbing. just getting the parts that we could to make this thing happen. This is just a typical Logitech webcam, I believe 1080p. We have another one for the other side, but I think we're actually going to move it here. We're going to try to continue to work on it. What I wanted to do was take the time to show you that if you're interested in robotics, and we're going to do a great series on this and some of the algorithms we're looking at. Jack and I have a lot of work to do and do videos. But I don't want to just show the robot driving. I want to explain that if you're really interested in robotics, it doesn't take a tremendous amount of money. I think you're looking here, what do we have in this?
Maybe $200 total, including all the computers.
Probably $350 because the battery.
Oh, yeah, because the battery was a lot.
Battery was kind of a lot. It doesn't cost a lot of money, and you don't necessarily need to buy one of those kits. You can start building it and create a really fun,
basically from nothing, because this was all basically junkyard parts.
Yeah, so the computers were all purchased. The safety stuff is purchased. There was a safety stop, so if you're interested in building one, I highly recommend safety first. There is a safety stop that we ordered that came in that was broken, so we had to send it back. But I want something on there where it could just be slammed and it shuts it off. Your goal is to create as safe of an environment. I mean, remember, if you end up working with a platform like this, there are other smaller platforms that you might use. If you work with a platform like this, you want it to be safe because remember, it's got enough power to be able to carry somebody around. Now, with this particular setup, we started off with a keyboard control. So left and right arrows, forward, back. It was very hard to get accurate driving on. So our goal is to record the videos and then use it to build a model. To train it. But what we found was we needed more accurate driving. The more accurate driving, the more accurate our model could be. So we found some old Stadia controllers. If you're not familiar with Stadia, it was Google's gaming. It was awesome. A lot of people didn't like it because it had a lot of lag, but the only thing you needed to play games was the controller. So we had a few of those. Jack and I used to like that. And they're Bluetooth, and so we were able to write a little software that turned instead of using keyboard inputs, it would take the Stadia controller, little Bluetooth controller, and just a regular video game controller. And it would take that and turn that into the commands that we need. So we talk to the MacBook Air. The MacBook Air sends the commands to here through WebSocket, through a Wi-Fi connection. So everything, if you're familiar with networking, everything's sitting on the same DHCP server from the Wi-Fi unit. So we have a Wi-Fi network. And then we can just address things across the IP. So we just are making WebSocket command calls to this particular IP address for our Aurdino. And that particular Aurdino gets, we have forwards, backwards, and then we have left and right motor speed. So we're using PWM commands there. And that's how we're building our model. We've got a lot of things that we want to talk about, and we're going to continue to work on it. I could tell you some of our future videos that you're going to be seeing from Rocket Van. We've got what we're talking about using Kafka. And if you're not familiar with Kafka, it's kind of like a messaging bus where you're sending messages across, because we're going to start treating all of these pieces of infrastructure. In a car, you would have CAN bus. So like in a Tesla or
any other car, really.
Any other car, Sprinter van, whatever you want, the Rocket Van, everything uses CAN bus. Another way of doing that in computer messaging is like the Mosquito or MQTT. So we're going to look at implementing some kind of message bus so we can create the logging. My main goal is when we're driving this and we're recording it, when it's doing good, I want to be able to capture that data so I can later use that to build an autonomous model. And I'll let Jack tell you a little bit. I'm going to come on this side, let Jack come around. And I'm going to let Jack tell you a little bit about what his experience has been, because we've gotten a few problems that have come out from a stable platform that I know Jack has talked about, and I'm going to point at the wheels because I know Jack wants to work on these. So Jack, you want to say anything about the wheels?
They're great and they're bad all at the same time. So one of the main things is when you're driving, you want a very stable image, because if you're using computer vision like we are, it needs to be relatively stable and not super noisy and bouncy. Now you can fix that with filters, but it's better to not have the problem in the first place.
The terrain is what he's saying, is it makes it bounce. Yeah. We're going to do this in one cut, Jack. This is not going to be our normal
No, it's not.
editing. You know, we're not great. You'll probably hear some wind noise. We're going to work on that. We've got a lot of stuff, but we really do want to share what we're doing with robotics. You know, Jack is interested in mechanical engineering or some kind of, he likes rockets, hence Rocket Van. He wants to be an engineer of some sort. So it's going to be our project we're working on right now. And Jack's been working on the Kalman filter, right? So can you tell me a little bit about what you're doing or what the upcoming video on that will be?
So my thought for the video tracking, so one of our big problems is getting it to drive a straight line. Believe it or not, that's super hard to do on a vision-based system and just on really any robots at all, because no parts that you use would be the exact same or so standard that you just turn on and it goes straight. And not to mention, your terrain's not going to be great, so you'll be wobbling and bouncing. Just like we were talking about with the camera, it's not a great platform to have very fixed and solid things because you're going to be moving and bouncing a lot. So one of the things we're doing with the Kalman filter is this was a different use of the Kalman filter, I guess you could
Well, it's
say.
kind of like how Ingenuity did it, right? Like they would find a point in the distance, and then they would lock in on it, and then
track it where it moves, and then they go to the next one. Because
Yep.
they know relatively where the other one is, so they can track where they're going over ground because they have a ground-facing camera. But what we're doing is we're going to have a few points in the distance, maybe on the horizon, wherever you can see it. And then we're going to have those points. We're going to say when we tell it to drive straight, we're going to set a few points on the horizon that we can see. And then we're going to put them in a vertical line so that as the robot turns or moves, that vertical line will shift from center. So you'll know how far you are from center so you can correct to go back to that straight line or to that target.
And that's going to be a great video. You know, there's so many topics that come up here with robots. Optical flow. Jack talked about there's no standard way of like, how many times does this wheel turn? Well, that's called odometry, right?
They're a lot different.
Yeah. So you don't get an exact one. So then you end up what's called a PID loop, which is proportional, integral, and derivative, which is a standard mechanism for, or algorithm for being able to compensate for like getting straight line driving or something like that. You're always trying to track it. I think they use it a lot in robots. They use it in temperature controllers. They use it in anything that where it's not accurate and they want to get somewhere.
And you have to target something.
And you want to target a center. So we didn't have the MacBook Air. That's the brain. Goes right there. This is a cheap piece of plywood. I think we might have got this at Lowe's, so the orange, don't let Home Depot confuse you, but I'm not against Home Depot. I just think this one came from Lowe's. But for the most part, if you're interested in robotics,
it's easy to do. You just got to find your parts.
When you're young and you don't have a lot of money to spend, find your parts.
Yep.
Make it safe. Safety first. Jack will tell you, when he's working on it, what do you have?
Safety.
Eyeglasses. And
any safety precaution that would be necessary.
Yeah, you want to be very, very safe. I'd also recommend starting with something at a lower voltage. Don't run something at a really high voltage. Most of these things are like 5 volts or 3 volts. Lots of breakers, fuses, cutoff switches. Safety every chance you get, because it only takes a second to cause a problem. Also, I tend to not allow Jack to charge these in the house at night. These can only be charged outside. I think they're probably pretty safe and stable. I just, you know,
when they go bad, they go really bad.
Well, and lithium iron phosphates tend to be more stable. But you just want to maybe watch when you're charging it, or especially at a high rate or when it's nearly fully charged.
A lot of people who are constantly charging batteries, like for RC enthusiasts or like camera photography people, they will have a box and bag or whatever method they design that's for fireproof.
Yep, those are lithium polymers.
Like a big fireproof box that they can put everything in and charge them. And that's just another safety precaution. It doesn't take but a few minutes extra of your time to instill that safety method and mechanism into your just plan for being safe with things that are hazardous.
So
can be hazardous.
I want Lehawn. Let's get Lehawn's head going over here. So we're gonna get this back up. It's got to make an approach. But see, that cardboard didn't cost us anything but a little green spray paint and some tape. So you don't have to spend a lot of money to get into robotics. but you do have to spend a little bit of time. And I hope this is gonna, in our video series that we're really gonna go to work on this, gets you to understand a lot of these algorithms and technologies that do things like build the Mars rover. So for Rocket Van, I'm Chad.
And I'm Jack. Roger. Over and out.